In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice? A flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision, could manipulate this elusive medium. His melodies, a symphony of science, had the potential to shift the very fabric of reality. However, a sinister force lurked in the shadows. The Einsteinian demons. These creatures thrived in the
All right, Toby, we're live.
Hello, hello, and welcome to Ether Cosmology Reading Night number 19. We're going to do some Redshift reading tonight, some more from Halton ARP, and then possibly dive back into the Shankar physics. We're going to see who shows up and if we have kind of see where things go. So right now we're going to dive back into what we read a couple weeks ago, Halton ARP's Seeing Red. And last week we kind of jumped into the middle of the book and just started reading about the Einstein cross and the stuff he was talking about surrounding that. But this week we're going to just start right back at the beginning. So we're going to do a little bit of a time travel here and go back to the introduction. But just because the book seems so good that I kind of figure we might as well just start at the beginning here and see maybe we can kind of work our way through it over time. Um, but in any case, if you are not familiar on now we do this on Monday nights. We used to do it on Thursday nights, but when we do these reading nights, it's not necessarily to present something that's uh, put in a pretty package for you for the listener, but rather we're just literally reading live on the spot. So if that's not for you, then feel free to tune out. But if it is for you, if you're interested or if you want to come and read along with us, feel free to join us on Discord. Go to ethercosmology.com, click the little Discord icon on the left there. And if you have Discord, you can hop in here and come read with us sometime. We do it every Monday night here at 9 p.m. So yeah, without further ado, let's go ahead and jump into Halton ARP's Seeing Red. So, why are redshifts the key to extragalactic astronomy? Redshifts, if we look at the light from an object after it has been spread out from short to long wavelengths, we will see peaks and valleys due to emission and absorption from its atomic elements. One thing we can then measure is how much these features are displaced from their wavelengths in a laboratory standard. It turns out when we observe galaxies and quasars, such features are generally shifted to longer wavelengths, in some cases by amounts of up to 4 or 5 times the local laboratory values. This redward displacement of lines in the spectrum is considered to increase with distance and to be the most significant information we have about the faint smudges that are supposed to represent the most distant objects we can see in the universe. But if the cause of these redshifts is misunderstood, then distances can be wrong by factors of 10 to 100, and luminosities and masses will be wrong by factors up to 10,000. We would have a totally erroneous picture of extragalactic space and be faced with one of the most embarrassing boondoggles in our intellectual history. Because objects in motion in the laboratory, or orbiting double stars, or rotating galaxies all show Doppler redshifts to longer wavelengths when they are receding, it has been assumed throughout astronomy that redshifts always and only mean recession velocity. No direct verification of this assumption is possible, and through the years, many contradictions have arisen and been ignored. The evidence presented here is, I hope, convincing because it offers many different proofs of intrinsic, non velocity redshifts in every category of celestial object, from stars through quasars, galaxies, and clusters of galaxies. Moreover, this one key observable will ultimately lead us to consider a universe governed by the non local effects of inertial mass and quantum mechanics. rather than the local dynamics of general relativity. Cosmology. Because it concerns our ultimate origins and our future destinies, many people are interested in the nature of the universe in which we live. We call this the picture of our environment in its broadest possible sense, cosmology. Really quick, Alan, do you have a copy of this, correct?
Yeah, I think so.
Can you drop it in the Discord chat for me? I told Stone I would and I forgot to.
Oh yeah, no worries.
Cool.
I'm just seeing red.
Many thanks.
Yeah, gotcha.
There, yeah, seeing red. Yep. There is now a fashionable set of beliefs regarding the workings of the universe, greatly publicized as the Big Bang, which I believe is wildly incorrect. But in order to enable people to make their own judgments about this question, we need to examine a large number of observations. Observations in science are the primary and final authority. In the present book, I endeavor to discuss these observations in as much detail as necessary to understand them. If the basic data were not so fiercely resisted by conventional cosmologists, the details would not need to be extensively discussed. But as it is, each block in the edifice has to be defended against the endless objections. Moreover, the link between many different results is what ultimately gives the whole new picture credibility. The separate observations have to be related to each other, and this takes some patience and effort, although it is exciting to see the pieces fit together in the end. In order to make this process more stimulating, I recount some of the personal and human reactions that accompany these events. This, I hope, will aid the reader in understanding not only the facts, but why they have been received as they have. After all, science is a human undertaking, and people will only read the detailed scientific evidence if someone speaks freely about what it means in the context of real human beings. Academia. Experts in physical science now are almost exclusively trained in universities. Our society financially supports theoretical scientists and facilities primarily through the academic hierarchy. So there is another reason why it is not sufficient to just relate the new factual results. The current beliefs are the crowning achievement of our research and learning institutions. And if they are so completely wrong and have been wrong or have been for so long in the face of glaring evidence to the contrary, then we must consider whether there has been an overwhelming breakdown in our academic system. If so, we must find out what went wrong and whether it is possible to fix it. In order to put the pertinent observations into their proper perspective, I present the following table, which gives a loose outline of modern cosmology. Table 1:1 Key Events in Cosmology. 1911, W. Campbell, Redshifts of OB stars with the K effect. 1922, Alex Friedman. Actually, I don't know what A stands for. A. Friedman, solution of Einstein's field equations. 1924, Edward Hubble, island universes, and 1930, redshift relation. 1948, J. Bolton, double lobed radio sources. 1963, Palomar quasars. 1970s, G. Devaucouleur.
Vaucouleur. Vaucouleur.
Vaucouleur, G de Vaucouleur, local supercluster, 1980 satellite X-rays, 1990s observatories with gamma rays, and then the cosmic ray telescopes with ultra high energy cosmic rays. Future redshift as a function of age, quantization of redshift, episodic creation of matter, Mach generalizes Einstein, mass as a frequency resonance. Oh, oh,
I like the sound of that. Pun
wow!
intended.
I didn't know he. Yeah, okay.
Oh, you dabble, do you?
Yeah, right. Key events in cosmology, the theory. It is currently believed that rigorous cosmology started in the early 1920s after Einstein wrote down the equations of general relativity. These essentially represented the conservation of mass, energy, momentum, etc., in the most general possible coordinate system. In 1922, the Russian mathematician A. Friedman solved these equations, i.e., showed how the system would behave in time. It is interesting to note that at first, Einstein felt this equation was incorrect. Later, he said it was correct, but of no consequence. Finally, he accepted the validity of this solution, but was so unhappy with the fact that it was not a stable solution, i.e., it either collapsed or expanded, that he retained the cosmological constant he had earlier introduced in order to keep the universe static. This constant was later referred to as the cosmological fudge factor. Huh.
So
In-
clinical.
So the way they talk about that fudge, that lambda now, is they're like, oh, you can just ignore that and set it to 0, but it's actually mandatory to be in there to balance it out. To balance it out, then, huh? That's unfortunate.
So in 1924, Hubble persuaded the world that the white nebula were really extragalactic. And a few years later announced that the redshifts of their spectral lines increased as they became fainter. This redshift apparent magnitude relation for galaxies became known as the Hubble law, through lack of rigor, often referred to as the redshift distance relation. At this point, Einstein dropped his cosmological constant as a great mistake and adopted the view that his equations had been telling him all along that the universe was expanding. Yeah. Let me get a little highlight going here. Thus was born the Big Bang Theory, according to which the entire universe was created instantaneously out of nothing 15 billion years ago. Boom. Who could refute such a thing? This really is the entirety of the theory on which our whole concept of cosmology has rested for the last 75 years. It is interesting to note, however, that Hubble, the observer, even up to his final lecture before the Royal Society, always held open the possibility that the redshift did not mean velocity of recession, but might be caused by something else. That's interesting. Oh, sorry, everybody. What in
What
the?
could it be?
There we go. Key events in cosmology, the observations. In 1948, John Bolton discovered radio sources in the sky. Martin Ryle, a reigning pundit, argued furiously that they were inside our own galaxy. Of course, they turned out to be overwhelmingly extragalactic. The curious thing was that they tended to occur in pairs, and it was soon noticed that there were galaxies between the pairs. I remember the noted experts of the day assuring us that the pairs had nothing to do with the galaxies. Then radio filaments were found to connect these pairs. They later came to be called radiolobes to the central galaxies, which were generally weaker radio sources. Without even raising a glass of champagne, people began to think that they had always known that radio sources were ejected in the opposite directions by some explosive activity in the central galaxy. This fundamentally what?
Well, duh.
Yeah, you didn't know that? We've always known that and thought that.
Of
Duh,
course.
my cat knows that.
Yeah.
So radio sources were ejected in opposite directions by some explosive activity in the central galaxy.
Came out of that black hole in the middle.
It just, sometimes explosions shoot things in multiple, they suck things in while they shoot things out.
It's a multi-vector ejection. Like, what do you mean? Nothing going on here.
Somehow always in the direction of Earth.
Yeah, always relative to Earth perfectly. All right, so this fundamentally changed our view of galaxies rather than vast, placid aggregates of magically orbiting stars, dust, and gas. It became clear that their centers were the sites of enormous variable outpourings of energy. Probably this change of concept has still not completely sunk in for many astronomers. It is astonishing to note how closely the X ray pairs across galaxies now correspond to the ejected radio pairs, and how stubbornly people refuse to accept them as ejected. Wow. This whole paragraph, man.
And we're just getting started.
Yeah, this is a pretty solid book. All right. So this is Stone's favorite type of art. He said if anyone wants to buy him a nice print of these, he will put them on the wall in his living room, giant, as big as possible, he said.
Right next to my Krasniansky, for sure.
The radio galaxy Cygnus A showing ejection of high energy radio emitting material in opposite directions from the central object. This map was measured at 5 gigahertz with the Very Large Array at Socorro, New Mexico by Rick Perley. Socorro.
Looks
Wow.
like somebody vaping through a hole in a door.
Yeah, it kind of does. But okay, we can keep going. Figure 1-1 here shows the radio image of one of the first double-lobed radio galaxies discovered, Cygnus A. Seeing the thin jets leading out into the swept black lobes leaves no room for doubt that this is a result of ejection from the central object. Something initially small and associated with radio emission has had to come out from the center of this galaxy. Quasars are also often radio sources, and many examples will be shown in this book of pairs of high redshift radio and X ray emitting objects, obviously ejected from the active central galaxies. The reason, of course, for the rejection of the pairing evidence for quasars is the now sacred assumption that all extragalactic redshifts are caused by velocity and indicate distance. The association must be denied because the quasars are at much higher redshift than the galaxies from which they originate. So, yeah.
Oopie.
So, quasars. In 1963, some radio sources which had been identified with apparent stars were being studied spectroscopically. What were puzzling stellar spectra, however, suddenly turned out to be emission line galaxy spectra shifted to very long wavelengths. There was some hesitation at first about accepting these redshifts as due to recession velocities uh, that approached the speed of light, since this would indicate great distance. At their redshift distances, these objects had to be 1,000 and in the end 10,000 times brighter than previously known extragalactic objects. I think this is kind of what we touched in a little bit last week when we were reading ahead. But no other redshifting mechanism was deemed likely, and everyone soon got used to these extraordinary luminosities. Ain't that the truth? Although the radio positions came from various observatories, the spectroscopic identification was mostly at the Palomar 200-inch reflector. I was observing at Palomar at the time, but the positions were distributed privately. So I instead undertook a multi year study of peculiar galaxies with the aim of studying how galaxies were formed and evolved. When the atlas was complete, I discovered that across my most disturbed peculiars were pairs of radio sources. Very nice. Obviously, the disturbance had been caused by the ejection of the radio sources. Then came the shock. Some of radio sources turned out to be quasars, and the galaxies were not at great distances, but relatively close by. Suddenly, it is 30 years later. I am living in Germany and observing by satellite, computer processing the data, and writing about all the exciting new pairs of X ray quasars across active galaxies which are being discovered by the Rosat satellite telescope, whose headquarters are located in the institute next door. There is only one little flaw in my idyllic good fortune, and that is that there is a relentless effort to ban all those lovely new observations from conferences and suppress them from publication. The compensation is that a few courageous and officially disparaged scientists are meeting and communicating with one another to explore the fundamental meaning this new information holds out to us. Hey, it sounds like the boys.
Yeah, the boys are getting together for a little round table, little cosmology round table,
Yeah, they're do a little reading maybe.
sharing some
Since the
extra
19
galactic photographs.
Yeah, maybe do a few of those after we're done here. So, high energy radiation and the local supercluster. Since the 1980s, not only have satellite telescopes been telemetering down X ray data, but more recently, higher energy gamma ray data has been gathered, and now ultra high cosmic ray detectors on Earth have been reporting even higher energy radiation. In a separate chapter to follow, we will discuss the concentration of this energy at the center of our local supercluster and its possible meaning. But first, we should briefly describe the local supercluster because, contrary to common belief, this may be the only region of the universe we know much about. The empirical results of galaxy catalogs were already showing in the 1950s that galaxies were not distributed uniformly over the sky. Yet the analyses by Gerard de Vencoulé showing the
Vaucouleur.
Vaucouleur showing the distribution along the supergalactic equator and the concentration along the Virgo cluster at the center were privately ridiculed until suddenly in the early 1970s everyone discovered that they had known all along. It turns out that we had to find the oldest galaxies there and the most energetic radiation, perhaps pointing to current matter creation. Hmm. Virgo may thus be a very special place in terms of understanding what we can currently see of our universe. Future events. At the bottom of table 1 some current investigations are listed. The investigation of redshift as a function of age already started in the early 1970s. The quantization of redshifts shortly after, and the creation of matter perhaps in the 1980s. Since even the existence of these effects is not accepted at present, we can only say that they are epochal science in the making, if they are someday accepted. Quantization of redshift and episodic creation of matter combine to offer the most promising empirical understanding of extragalactic objects as explained in the following chapters. As a capsule preview of how galaxies are born, we can say that they are ejected from older galaxies as compact objects with low particle masses. As these newer galaxies age and grow in size and mass, huh, they in turn eject newer generations in a cascading process. We can actually show in chapter 8 how groups of a dozen or so active quasars fraction into more and more objects, which in turn eventually evolve into clusters of large numbers of galaxies. Oh, yeah, okay. There must be a bunch of rocks and stuff. The redshifts, which are very high as the newly created matter emerges from its zero mass state, continue to diminish as the mass of the matter grows. Discrete steps in the redshift values are present throughout, but grow smaller when overall redshift grow smaller when the overall redshift grows smaller. These aggregates of matter develop into normal galaxies, much like our own, and those around us in the local group and the local supercluster. Huh. All of this is almost diametrically opposed to the conventional view of galaxies condensing out of some tenuous, homogeneously pervading hot gas. It is a process that is going on in our own local supercluster, and contrary to what is claimed by the Big Bang theorists, we do not know much about what may exist at cosmic distances. There you go. There you go. Turns out that for what we currently see, but do not understand, the essence is in the changes it is undergoing. All right, I'm glad he said that because that was what I was. I mean, this is. I'm going to highlight that red because that's spot on. Um, So, contrary to what is claimed by the local or by the Big Bang theorists, we do not know much about what may exist at cosmic distances. I mean, and that's just common sense. And it turns out, for what we currently see but do not understand, the essence is in the changes it is undergoing. So that's all we can really look at, right?
I'd like to hear a few guesses about where all of this extra mass is coming from. All these galaxies are growing and expanding and spawning. What are they spawning, and how is that getting there? And how is it all just ignoring Newton entirely gravitationally and just firing these things off? Where is all that force coming from?
Yeah,
It's
it seems
considering we're billions of years into this process now, right? Wink.
right. Yeah, according to them, it seems like they are probably quite wrong about the nature of the makeup of it as far as it being, what kind of quote unquote matter it is. Is it even, physical? And then the distances and sizes, of course, as well.
That leaves you with the question, did they get any of it right?
Yeah,
Not
right.
at all. Not at all.
No, that's not looking good. Not looking good. The final possibilities for a more fundamental understanding of the nature of matter as a function of frequency and time will be discussed at the end of the book. That will be interesting. We'll have to make sure we get to that at some point. A complete understanding might be the ultimate reward for a careful analysis of all the observations. It is clear, however, that if we are to make progress in this area, we cannot wait for establishment science to, perhaps someday, accept the empirical results. Ain't that the truth? Says so much good stuff. When the first telescopes were being built under clear skies and systematic spectroscopic observations started, for example, with the 36-inch refractor at Lick Observatory on Mount Hamilton, it was natural to observe what one could. That meant bright stars. One of the things that could be measured accurately was line shifts in stellar spectra. As the data accumulated, it was noticed that the bright blue OB stars, the hot luminous stars, had lines which were slightly but significantly shifted to the red. In 1911, the director of the observatory, W. W. Campbell, gave the enigmatic name K effect to the phenomena. Actually, K represented the expansion term in the formula that described the motion of all the stars measured. Since all the other stars in our galaxy moved together in reasonable ways, it was not concluded that we lived at the center of an expanding shell of OB stars. Huh. The effect was unexplained until the 1930s, when Robert Trumpler again found the effect in clusters of young stars in our galaxy. He thought he could explain it with a gravitational redshift at the surface of these hottest, most luminous stars, but that failed when the surface gravity turned out to be too weak. Later, Max Born and Erwin Finley Frundlich tried to explain it with tired light, but that did not catch on. So the observations were again buried and forgotten. Nice try, boys. I think it is a supreme and delicious piece of irony that 85 years after the director at Lick Observatory announced the K effect, Margaret Burbidge, a senior professor at the University of California, went up to Mount Hamilton on a winter night to the same Lick Observatory. She observed two quasars that all the biggest and most advanced telescopes in the world had deliberately refused to look at, and in doing so, solved the riddle of the K effect, and at the same time laid the last flower on the grave of Big Bang cosmology. Looking back now, especially from the standpoint of the upcoming chapters, we can see that if the relativists had heeded the published observations going back a decade before their theoretical revelations, oh, those risky predictions are getting them. Perhaps they would have decided that the universe was not necessarily exploding away from us in all directions. My career at the observatories in Pasadena slightly overlapped Edwin Hubble's. He personally gave me my first job to aid in determining the crucial distance scale in cosmology. As a result, I lived for 2 years on Mount Wilson. Shout out. Measuring novae in the Andromeda Nebula M31. I moved on to observe Cepheid variables from South Africa, and finally am now presenting evidence for a much different, perhaps truer distance scale at greater distances derived from quasars and young galaxies. In his seminal book, Realm of the Nebulae, Hubble wrote, on the other hand, if the interpretation as velocity shifts is abandoned, we find in the redshifts a hitherto unrecognized principle whose implications are unknown. Huh. In the ensuing years, the evidence discussed in the present book has built up to the point where it is clear that the velocity interpretation can now be abandoned in favor of a new principle which stands on a firm observational and theoretical foundation. Hmm. I'm excited to see what you got, Mr. ARP. After 45 years, after about 45 years, I now know that if the academic theoreticians at that time had not forced his observations into fashionable molds, we might at least not have started off modern cosmology with the wrong fundamental assumption. We could be much further along in understanding our relation to a much larger, older universe, a universe which is continually unfolding from many points within itself. Popcorn to the room.
I got you.
All right.
All right. X-ray observations confirm intrinsic redshifts. Scroll down a little bit. All right, just another isolated case. Your eye slid over the phrase because you didn't want to see it, whether the reference was going to recommend or whether it was going to whether the referee was going to recommend publication. The answer was not for the astronomical journal letters. The message behind the smooth, assured phrase was clear. No matter how conclusive the evidence, we have the power to minimize and suppress it. What was the evidence at the time? Just two X-ray sources, unmistakably paired across a galaxy well known for its eruptive activity. A paper reported that these compact sources of high energy emissions were both quasars, stellar appearing objects of much higher redshift than the central galaxy NGC 4258. Obviously, they had originated from the galaxy in contradiction to all official rules. Slyly, the referee remarked that because there was no known cause for the intrinsic excess redshift, the author should include a brief outline of the theory to explain them. My mind flashed back, though 30 years of evidence ignored by people who were sure of their theoretical assumptions. Anger was my only honest option, but stronger than that, provoked by many worse, the quote-unquote peer review, because of this was not even my paper. I did not have to stop and worry that my response was ruled out by wounded personal ego. How did that latest skirmish begin? Several years earlier, an X-ray astronomer had come to my office with a map of the field around NGC 4258, and there had been two conspicuous X-ray sources paired across the nucleus of the galaxy. He had asked if I knew where I could get a good photograph of the field so he could check out whether there were any optical objects in which could be identified with the X-ray sources. I was very pleased to tell him I was very pleased to be able to swivel my chair around the bookshelves in the back of me and pull out some of the best prints in existence of that particular field. I had taken it with the Kitt Peak National Observatory 4-meter telescope about a dozen years previously. Here we go. Nice black and white photo for Stone.
Stone, that one's going to look really good on your bedroom wall.
Devoid of all meaning and purpose.
Yes, that one's going in the foyer for sure, man. Yeah.
Nice.
Cosmic paramecium.
Okay, so was very deep because I had been searching for the active galaxy for a low surface brightness ejection features associated with the high redshift objects. Wolfgang Petsch quickly found a small pointing correction to the satellite position, established that his X-ray pair coincided with a blue stellar object at about 20th apparent magnitude, figure 1-1. At the instance, I knew that the objects were almost certainly quasars, and once again experienced that euphoria that comes at the moment when you see a long way into a different future. In the view of the obvious nature of these objects, I felt that. What is this guy's name, Stone?
Peach.
Peach? Okay, Peach showed courage and scientific integrity in the publishing of the comment. If the connection of these sources with the galaxy is real, they may be bipolar ejecta from the nucleus. Nice. Took a lot of integrity to say that it could be bipolar ejecta from the nucleus. Shout out to you, boy. Let's see. Then this dance of evasion began. It was necessary to obtain optical spectra of the blue stellar shift candidates to confirm that they were quasars and uncertain of their redshifts. A small amount of time was requested for the appropriate European telescope. It was turned down. Peach's eyes avoided mine, and he, oh no, and he's about to lose his integrity. And then he said, I guess I did not examine it clearly enough. Oh no, Peach, the director of the world's biggest telescope, or largest telescope, and requested a brief observation to get the redshift, said it was not done. The director of the X-ray Institute requested confirmation. It was not done. Finally, nearly 2 years, E. Margaret Burbage, with a relatively small 3-meter reflector on Mount Hamilton on a... Second.
On a cold winter night.
On a cold winter night, against the night glow from San Jose, recorded the spectra from both quasars. It was fortunate that the mandatory requirement had been abolished in the U.S. because Margaret had over 50 years of observing experience. The mandatory, what was abandoned? Fortunate that the mandatory mandatory retirement. Okay, I was going to say what the hell did I just read? All right. Of course, the referee report from which I quoted was directly against her paper, in which the report, this new important observation. I was quoted with the direct. I was quoted directed against her paper, which reported this important new observation. In the firm but ladylike English way, Margaret withdrew her paper from the Astrophysical Journal Letters and submitted it to the European Journal of Astronomy and Astrophysics Letters. So she submitted it to a predatory journal, guys, or whatever.
Gave it to their competition for sure.
Oh, a crackpot journal.
Crackpot, dude. One second, I gotta get some water here. What was particularly appalling about the series of events was that Margaret Burbage was someone who had given a long distinguished service to the scientific community, professor of University of California, director of the Royal Greenwich Observatory, president of the American Association of the Advancement of Science, and among other contributions. It seems it was permissible to let her fly anywhere in the world to do onerous. What is this? Doing onerous administrative tasks, but in her scientific accomplishments were not to be recorded for elementary scientific respects of her fair treatment. Nice. Some would argue that this is a special case owing to the climate of opinion where the offices of the Astrophysical Journal Letters are located. But as events in the following chapters make clear, the problems is persuasive throughout astronomy, and the contrary to the projected image, the epidemic throughout the most of the current science. Scientists, particularly at most prestigious institutions, regularly suppress and ridicule findings that contradict their current theories and assumptions. Dude, no way. They're not always good. Dude, weren't we told that they go to work every day trying to disprove one another and like it's all just fun and games? And if you can disprove the other guy, you get more famous. You get more famouser.
People think that they went and studied finance, like they're like trying to get rich. No, they went and studied science. They're trying to do science. They don't care about like money and stuff. They don't care about that. They're all doing science.
It's crazy.
Simple. Everyone's objective.
Oh yeah.
Clearly. Always.
And there's no bias.
No institutional bias.
They train you to remove your bias in science school.
If my institution tells me, hey, you need to stick with this theory, or we're probably gonna kick you out of class, then obviously I'm gonna say, well, then kick me out. And then they're gonna be like, no, we wouldn't actually do that. And then they're gonna promote me and give me a Nobel Prize.
I think that's how it works.
Yep.
So
Okay, sorry, continue.
you're good. Since scientific research in the end is almost completely supported by public funds, it behooves us as citizens to be aware of whether this money is spent wisely in relation to the real needs and possibilities for the future of society. The central purpose of this book is to explore this topic, and we will return to it often. But in the case at hand, the greatest progress can be made by discussing the actual observations of how nature works and the ways in which science often misrepresents and misinterprets them. Just another experimentum crucis, NGC 4258. The referee's unconscious satire, just another isolated case, was accompanied by the depreciatory remarks.
Deprecatory.
Thank you, sir. Deprecatory remarks that such quasars are not well aligned and that they are not exactly spaced across the nucleus of the galaxy. Of course, a normal person would simply glance at the pair of X-ray sources across NGC 4258 and realize that they were physically associated. Oh, no way. They're just like connected by a filament? That's crazy. And the average astronomer, however, would look at them and start to argue that they must be accidental because astronomers now feel compelled to fit the observation with the theory and not vice versa. Unlucky. Consequently, to head off the derogatory rumors which pass for scientific evaluation, someone had to compute a numerical probability. Basically, this means computing how dense the associated X-ray sources are on average over the sky at any given apparent brightness. Then I had to ask myself, what is the chance that the source of the given brightness falling to close to an arbitrary point in the sky? Given the chance that the first one falls accidentally as close to the measured distance, then one must multiply by the chance of the second one that falls at its observed distance, i.e., if 1 out of 10 will have a source as close as the real one, then only 1 out of 100 will have 2 of such sources. So for 2 sources across NGC 4258, it turns out that the exact chance is 5 times 10 to the minus 2, i.e., 5 chances in 100. Of course, this does not include the probability that they would be aligned across the nucleus of NGC 4258 within 3.3 degrees out of the position, or probable 180. Let's take a quick gander at that beauty. Look at that. So my favorite part is the gradient of gray.
I think that one would go well. You could put that one above. Maybe
I'm
above
selling that one on eBay. Fuck it.
Dude, how do we get a color copy of this book?
That one's gonna go for a lot.
Ever since Stone said that they were devoid of meaning, every time I look at them, I get sad now.
They are. This totally sucks that we can't have a color version, man. Like, what the?
Like, that's crazy, dude. What the heck, ARP? All right. Let's scroll down a little more. All right. Thank you, sir. All right. So the probable 180, nor does it include the improbability that they would be so equally spaced across the nucleus, nor does it include the similar strengths and energy distributions of the 2 sources, which would be expected from a random unrelated sources. Well, which would not be expected, sorry. Altogether, the chances of the X-ray pairing sources across NGC 4258 being accidentally only 5 times 10 to the negative 6, 5 chances in a million. When it was confirmed,
not bad.
It's pretty decent. When it was confirmed that, I mean, it's not my favorite drop rate. Like, I wouldn't farm that boss, but it was confirmed that for both sources were quasars, that their redshift became available. When it was confirmed that both sources were quasars, their redshift became available. It was immediately apparent to anyone experienced with quasar spectrum that the 2 were unusually similar, figure black and white. A conservative probability for this similarity can be estimated at 0.08. Therefore, the total probability of this association being accidental became less than 4 times 10 to the negative 7, less than 10 or 4 to 10 million. Dang it, it's not looking great. Scientists claim that for the acceptable scientific rigor, numerical probabilities must be calculated. But no matter how intimidatingly complex the calculation, no matter how small the probability of accident may be, the calculation does not tell you whether the result is true or not. In fact, no matter how significant, yeah, that's right. In fact, no matter how significant the number is, scientists won't believe you. You won't believe if they don't want to. Yeah, can you highlight that too? That they, at the end of the day, there's an ultimate nah factor that they can.
Shout out to the Globies.
Dude, it's like, seriously, what is the point of even like you're calculating a probability of your theory being true as if that matters? Like I get doing it to an extent, but like obviously when you're in that realm in the first place, you are way outside of the realm of any sort of meaningful discussion.
It's pretty awesome. When I submitted the paper with the calculations on NGC 4258, which were claimed to be scientifically necessary, it was not even rejected, but just put to an indefinite holding pattern, which would never be accepted upon to this day. Dang, dude, they just permanently iced your boy. Put him on ice permanently. In the case of NGC 4258, however, most astronomers overlooked a very important fact that this galaxy is not just another object in a sea of identical objects. It is one of the most active nearby spiral galaxies. In fact, in 1961, when the French astronomer G. Stone
Cortés.
Nice. Cortés discovered the glowing gaseous arms emerging from the center of its concentrated Seyfert nucleus. See the black and white. Seyfert, thank you. Seyfert nucleus, see figure black and white picture that no one will look at. It made the observations with the Westbrook radio telescope, which revealed that the protospirals of the arms were also sources of synchrotron radiation. Synchrotron?
Synchrotron? Yeah.
Synchrotron radiation. High energy electrons spiraling around magnetic lines of force. Discrete lines of force, guys. They're quantized packets. They're not lines of force that are continuous.
Ooh, thank you. That was really close. I almost thought it was continuous and not.
No. We're dealing with a field here that has varying fluctuations in it, but not anything real with continuous lines. Anyway, so let's see here. We got figure who cares. Scroll down. All right. In the past, I had argued with Jean Oort, the discoverer of the rotation of our own galaxy, about whether the spiral arms of the galaxy caused by the opposite ejections of from the active nuclei. NGC 14.
Do you guys recognize that name? Also from the Oort cloud?
I was going to say it does sound familiar. Is that an Oort relation to your boy?
That would be
Oort?
Jan Oort. Yeah.
Oh, Jan. Oh, thank you. Okay, so NGC 4258 is the only case in which he had ever admitted that the protospiral arms were being ejected from the center. The simplest and most obvious conclusion was that the pair of X-ray quasars was also being ejected from this unusually active galaxy. Interestingly enough, shortly after the discovery of the quasar pair, it was discovered that the water mazored emission from the H2O molecule. Oh, okay. In the inner spots, in the inner 0.08 arc second showed a redshift deviation of plus or minus 1,000 kilometers a second from the redshift of the nucleus. A conventional model explained this to be caused by the rotating of the black hole of a rotating black hole 40 times larger than the mass of even the largest previously hypothesized black hole. Nice, dude. They just invoked a bigger thing. They were like, hey, you know that thing that we can just put here with math? There's a bigger one than we previously used. It's awesome. Shout out to the boys. But just a glance at the observation and the figure that we're not going to look at showed that what was instead looked like entrained materials pointing out in either direction roughly towards the quasar. Note the quantitative agreement with this conclusion of Van der Cruyt, Oort, and Mathewson. Let's see, astronomy and physics.
Mathewson.
Wow, dude, I butchered that, huh? Wasn't even close. Dude, what was I thinking, dog? Matthew's son. Wow. Okay. So clouds expelled from the nucleus in two opposite directions in the equatorial plane about 18 million years ago at velocities ranging from about 1,000 to 1,600 kilometers a second. Even if the conventional hypothesis of a black hole were tenable, then the hypothesized mechanism of a bipolar injection valid for both of them, the observation would still testify to extreme activity of NGC 4258 and thus support the association of the quasars. I personally prefer the concept of a quote-unquote white hole, a place of things where they irreversibly fall out of rather than into. Nice, dude. Respect, dude.
Wow.
I bet you do.
That's gonna be my that's gonna be my go-to argument. I'm more of a white hole guy.
Fall out. Now,
Yeah,
isn't that the antithesis of Earth globy physics, where everything falls inward? Somehow, astronomically, things are falling outward of a galaxy.
What's an antipodal white hole or an antipodal black hole?
Dude, the theory of antipodes gets crazy when you get into black holes, but I like where your boy's taking it here. So let's see, where were we at? White holes irreversibly fall out into... Yeah, let's see. It says, for me, the whole lesson about the Atlas of Peculiar Galaxies was that the galaxies are more generally ejecting material. The merger mania seems to be a first guess based on a cursory look at galaxies. But I also think that the observations are not yet detailed enough to suggest a specific mechanism of ejection. Instead, the startling evidence of the association of the high redshift quasars to the low redshift galaxies needs to be faced. The observations are more likely to lead to an understanding of an ejection mechanism when responsibly pursued. Dude, you always pursue responsibly when you're dealing with redshift interpretations.
Only you can prevent astronomical misinterpretation.
Absolutely. We need to start up a like a MAD group, but for astronomers. So, of course, this evidence of association has been implacably rejected for over 30 years by influential astronomers. In the case of NGC 4258, just as described, the chance of accidental association is only 1 in 2.5 million. A reasonable response would be to notice such a case and say, if I see a few more cases like this, I will have to believe this is real. As most astronomers say, this violates proven fit. Hold on, I gotta get ultra robot. This violates proven physics and therefore is invalid. I think that's after all, not only how improbable is only one case. Then when we see another case, they treat it as de novo and reject it with the same argument. Nice, dude. Oh my God, dude. It's just the globe, man.
Right? You really feel where it's coming from.
Dude, it's all the same. They never stop. It doesn't get better.
I feel your angst, Mr. Harp.
It's like you're not gonna talk to one and then they go, "Oh, dude, you're super right. It's all wrong." Yeah. Anyway, so let's see. Professional scientists, however, have the responsibility to know about the previous case. And they do. When they block them out, it's the clear case of falsifying the data for personal advantage, a violation of primary ethic of science. Facts. In a more general perspective, it can be said that the unique capability of a human intelligence is pattern recognition, and that the most difficult task for a computer to perform. When one thinks about it, indeed, the seminal advances of science and perhaps human affairs and in general were made by recognizing patterns of natural phenomenon. Popcorn to the lads? Any popcorners?
You bet.
What?
You bet. Other cases of galaxy-quasar associations. In order to forestall this argument about NGC 4258 being just another isolated case, I realized that it was more or less up to me to try to publish a paper which established its relation to other similar cases. It would also be necessary to calculate the numerical probabilities in each case. As I've mentioned before, this is an obligatory exercise that critics do not like to do themselves, but insist on in any discovery paper. After the ritual argument about statistics is finished, is it 10 to the negative fifth or 10 to the negative sixth? The argument is sufficiently abstract that people who wish to disbelieve the result can ignore it, when in fact it would be embarrassing to ignore it as a straight judgment call from looking at a picture. Of course, the most important purpose was to gather together more examples of the same kind of pairing. That should clinch the issue. Table 1.1 is reproduced here from the paper that never appeared in Astronomy and Astrophysics. Already at that time, it showed 5 cases involving only X-ray pairs of quasars around lower redshift objects, each with a chance of less than 1 in a million of being accidental. All right, PG 1211 plus 143. For anybody who wants to know what that means, this is actually a declination kind of address to an address in the sky, an angle, and then the plus 143 I do believe has to do with a time reference. And what they're doing is they're pretending that everything in the sky is slowly shifting position. Like, because we're looking at such precisely small, teeny pieces of the sky with our big, giant telescopes, which is why we need lasers to help sight them now, that, 20 years later, say, you're looking in that spot for that, that particular thing in the sky, and it's just not going to be there. It's going to be shifted by a couple of fractions of an arcsecond in some direction. So that's how you know how to find it. Allegedly. That's really what that coordinate system is supposed to be compensating for, if you can believe it. Anyways, one of the cases in Table 1.1 became available in the following way. During the time it took for the redshift measurements on the NGC 4258 quasars to unfold, I traveled to the National Radio Observatory and gave a talk. Afterwards, Ken Keller, I bet it's Kellerman. I can feel it coming.
But real quick though,
Keep
don't
going.
you think that one would look really good on your kitchen wall? Maybe?
Oh yeah,
Above
that
the
looks like
stove?
COVID.
It does look kind of
That's X-ray COVID.
Oh,
Look
I
out,
think you
man.
had it.
Hey, nailed it. Kellerman came up to me and said, here's a bright quasar which appears to have a line of radio sources passing through it, and one of the radio sources is a higher redshift quasar. As soon as I returned to my office in Munich, I asked my friend and computer expert in the office, H.C. Thomas, to show me how to search the archives for any X-ray observations of this object. After 1 year, all proprietary observations are put in a public archive. But considering the amount of specialized knowledge one needs to access these records, the term public is rather euphemistic. An observation was found, and I eagerly reduced the approximately 4 megabytes of data, boy that's large, hey, to form an X-ray picture of the field. As figure 1.5 will show in black and white, the central object is strong in X-rays, and the radio quasar to the east is conspicuous. But most electrifying, good pun, there is the hoped-for strong X-ray source just on the other side to the west. I immediately went to the sky survey photographs and found that this latter X-ray source coincided with a blue stellar appearing object, that's your BSO, another pair of quasars across an active object. And this one was aligned with radio sources which by now are accepted as ejected from active galaxies. Oh joy and rapture. But now the same old problem, how to obtain a confirming spectrum and get the redshift. Big observatories were obviously out of the question. The quasar candidate was rather bright, however, and it probably could be observed with a smaller telescope. I sent the finding charts to, that's got to be Jayant Larlikar, director of the Inter-University Center for Astronomy and Astrophysics in Pune, India. Oh, sorry, it was Jayant Narlikar, and he is interested a young researcher in obtaining a spectrum with a 1 meter Vainu Papu telescope. Okay, which the observation was scheduled in April, however, and the monsoon moved in. Despair. It was gone for the year. Jian said that they had asked the Beijing Observatory to do it, but I did not take it that seriously because, to my knowledge, China did not have adequate equipment. It turns out, however, there is some reason to look for the front email because a month later I was delighted to receive a message that the spectrum had been obtained by the Chinese. Oh man. After some normalizing of photon counts, that little conspicuous phrase there, it was possible to derive a redshift of z equals 1.015. The confirmation of this X-ray BSO as a quasar was particularly compelling because PG 1112-143 had been noticed as a result of it having a line of radio sources across it. As we have discussed, flanking radio sources are customarily interpreted as arising in ejection processes. How else could this pair of X-ray quasars along exactly the same line have arisen? The numerical value of this redshift also turns out to be an important result. When included in Table 1.1, it showed that the difference of redshifts between quasars in the first three best pairs was 0.25, 0.18, and 0.26. In other words, interpreting the quasars as ejecta, the projected ejection velocities should be 0.082c, 0.058c, and 0.06c in kilometers per second. The coincidence of three independent determinations giving closely the same ejection velocity is very encouraging for this interpretation. Velocities can only be added as in 1 plus z sub I, 1 plus z sub v equals 1 plus z sub t, or I equals intrinsic, v is velocity, and t is total, as described in Chapter 8. Someday we'll get there, man. Cool. For an average projection angle of 45 degrees, this gives an average true ejection velocity of 0.094 c, or 28,200 kilometers per second. And it is baffling how they can ordinate any of this.
Yeah.
Oh man. Okay, radio pairs from 1968, 56 years ago. Several months after submitting this result, and in the midst of dealing with the usual hostile referee and nervous editor, I recalled a surprising fact. Back in 68, I had investigated pairs of radio sources in the sky, some of which had turned out to be quasars, with a big ol' asterisk we'll check out later. From the estimated age of conspicuous disturbances in the central galaxy, and measured separation of the quasars from their galaxy of origin, I had calculated ejection velocities of 1/10 of the speed of light. In fact, I had calculated ejection velocities only 5 years after quasars had been discovered by a completely different method, which now agreed well with the new measures. Of course, even so early in the game, such a storm had been raised against local quasars that there was no chance of publishing in a normal journal. As a result, I had published in the Journal of Armenian Academy of Sciences, Astrophysica. Victor Ambarzumian was a hero of science in Armenia. We agreed on his initial insight that galaxies were formed by ejection from older galaxies. He did not believe my evidence at that time that redshifts were not velocity indicators. But as a tribute to his fairness, he did not hesitate for a moment to welcome my paper. These 12 figures in that paper are dramatic proof that the X-ray results of 1994 had been predicted in detail by the radio quasars back in 68. The paper was also testimony to the fact that sensible analysis of observations was being blocked and ignored, while the high-profile journals were submerged with a flood of elaborations of incorrect assumptions which prevented anyone from remembering anything important for more than a few years. Okay, the asterisk. We just passed it. There we are. Reverse original discovery procedures, 1966. Instead of finding pairs of high redshift radio sources across distributed galaxies, I looked for pairs of radio sources on the sky and looked up to see whether the galaxies between them. Of course, many of the radio sources in the pairs turned out to be quasars. And that's something that kind of I was thinking while I was reading all that stuff too. Like, maybe they've got the timeline backward. Maybe the quasars have to pair up to produce a galaxy.
That's an interesting thought.
I can see that happening. In a resonant function, I can see that happening for sure. In the same way that sonoluminescence is a focused resonant process, I see continuity in function. Anyways, let's roll. All right, Fig 1.6 here shows a quasar pair from 1968 paper. The pair involves the brightest radio sources in the field and is so conspicuous that it's difficult to entertain any idea that it is an accident. Then, of course, there's the disturbed galaxy IC 1767 falling at the center of the pair. How likely is that to be an accident? I didn't know the redshifts when this pair was published in Astrophysica, but they were subsequently determined to be 0.67 and 0.62. Finally, out of a possible range for radio quasar redshifts from 0.1 over to 2.4, what is the probability of getting two unrelated quasars to have redshifts within 0.05 of each other? This result was then published in Astrophysical Journal, but with the same lack of result in the face of 28 years of accumulated evidence to go on proclaiming that quasars are out at the edge of the universe seems unpardonable. Macarian 205,
Wow.
the second entry in Table 1.1. What's up there, Toby?
Just quite a statement there at the end.
On
Maybe
and
worth a
on.
little
This guy is
highlight.
like, look, I'm telling him this, I'm telling him that, I'm telling him for decades, and everybody's la 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 la. I can't hear you, la 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 la.
Yeah. Yeah. Well said.
All right, second entry in that black and white table which yields a projected ejection of velocity of 0.058 times the speed of light, is from a famous and controversial association of a quasar-like object, Mark 205, with a violently disrupted spiral galaxy of NGC 4319. It is featured in color. Oh, where? On the cover of my book. Oh, well, quasars, redshifts, and controversies, and the long campaign to disprove the connection between the two objects is described therein. The connection was first shown in 1971, but as late as August 1995, there was still an exchange of letters in the sky and telescope, in which one of the original disputants continued to claim the bridge did not exist. The observations listed in Table 1.1 involved two new quasars and connections which were discovered in 1994. In 1990, the Max Planck Institute for Extraterrestrische Physik launched the X-ray telescope ROSAT, or Röntgen Observatory SAT Astronomical Telescope, and actually the telescope, a superior work of engineering, was launched by Delta rocket from Cape Kennedy, for which, plus one instrument, the US claimed 50% of the observing time, leaving Germany with 38%, Britain with 12%, for building a small ultraviolet camera. Observing time was assigned to proposals from each country by allocation committees in that country. By an enormous stroke of good grooming, good toothbrushing, good fortune, I was then a member of the German Institute and could submit proposals to the German Selection Committee. Even though I had been in Europe for 4 years, I still heard from friends in the US how my previous requests for time on ground-based telescopes and current space telescope requests had fared. Some second-hand accounts reported intense anger and ridicule expressed from the select group of the most reputable, but generally anonymous, astronomers who comprise the US allocation panels. My proposals to the German committee were rated very low, but at least the case was not hopeless. On the first few schedules, I only received time for one very harmless proposal, but some of the experts at the MPE, located next door, were very helpful in preparing the proposals in the most acceptable possible format, and in later scheduling periods, I received time on some hot objects. One of these was Mark 205. The proposal was to see if the connecting bridge from NGC 4319 to Mark 205 showed up in X-rays. As is often the case, the major aim failed. I think now the connection to the galaxy is too old to show well in high energy. But what did show up was two X-ray filaments coming out of either side of Mark 205 and ending on point-like X-ray sources. Front cover of this book, 1.7 and color plate 1.7. Oh, it's a color plate, is it? I immediately got out of the sky survey prints and superimposed, I think he means superimposed, scaled X-ray maps to see if they were optically identifiable. Lo and behold, they were not only blue stellar objects, but unusually bright in apparent magnitude.
All right, we gotta go to the cover real quick.
Go for it. Let's see it. I'm seeing
Oh,
red.
man, everyone, go get your copy of that
Looking right at you, bro.
to hang on your.
Dude,
Actually,
Toilet?
make a
Oh.
political sign. Put it in your front yard.
I see why he
That
left
one's
all
going
the
in the
other.
bathroom.
I see why all the other ones
When
are
I'm
black
when
and
I'm
white.
ejecting something, I want to be looking at that.
Well, you know those things they put at the bottom of a urinal to make you like read something when you're trying to vote?
The pucks.
Yeah, that's
The
where that's
pucks.
going.
Yeah, we got a triple shot of pucks there. Right on. Those are Ether Hot Pocket pucks.
Oh, there it is again. That's the black and white version. Pretty cool, huh?
Loving it.
Wait, isn't that
Loving it. Now we're down a fair bit. Keep going.
My bad.
Where are we at? Yeah, we did the Institute. We did the one of these. And we did the ending point like. We did that.
Here we go.
1-7 there. They immediately got out to the sky survey prints, superimposed, and yada yada. Of course, they're quasars. But how to get the requisite spectroscopy, which would give the redshifts? Same old problem. All the telescopes were occupied studying distant high redshift objects. Then a routine check of cataloged quasars bore unexpected good fortune. It turned out that a team of researchers had previously investigated fields around strong X-ray objects and found an excess of sources around Mark 205. The excess sources turned out to be mostly higher redshift quasars, but they rejected the significance of this on the basis that Mark 205 had been previously known to be in an active region. That's like Scooby-Doo print right there. Oh, row. I could almost forgive them for that inverted logic because I was so happy to see that the spectroscopy of the sources in the field. It turned out that there were 3 confirmed quasars in the X-ray filament that I discovered coming out of Mark 205 in the ROSAT observations. The 2 major ones at the ends of the 2 filaments are listed in Table 1.1 with their redshifts, which yield a projected velocity of 0.06 times the speed of light. Each average d-projected velocity of 0.08 c. As previously remarked, this now becomes a very important confirmation of the ejection velocities computed for radio quasars 27 years earlier. I told you so. But, of course, the stunning aspect of the ROSAT observations was that 2 quasars of redshift 0.63 and 0.45 are actually physically linked by a luminous connection to a low redshift object Z of 0.007. When I showed this to the local experts, there were alarmed stares followed by annoyance. Of course, if you go faint enough, you'll find noise features or instrument imperfections which connect everything together. The frightening aspect of this reaction was that they were saying, if the connection between these objects cannot be attributed to noise, there must be something wrong with the instrument. The latter possibility, even the mention of, is enough to freeze any member of a well-funded project in his tracks. Of course, I made the argument that since the filaments from Mark 205 were sufficiently broad, coherent features, they obviously could not be noise. I also reduced the exposure of a bright X-ray star in the same way as Mark 205 and showed that the faintest levels exhibited no imperfections, but just broke up into random noise as expected. Any non-expert would simply have reasoned that the instrumental defects would not likely originate just from an active object, and certainly there would be no reason for them to end on the quasars in the field. Nevertheless, it was clear that the best possible presentation of the data needed to be communicated. The communication was not easy. Both initial collaborators opted out because I mentioned the word ejection in connection with the filaments ending on quasars. This was just before the word was mentioned in connection with the pair of X-ray sources across NGC 4258, which later turned out to be quasars. Actually, I became somewhat worried that the pair across Mark 205 was not better aligned. In attempting to account for this, I pointed out that the connecting filaments started out from Mark 205 in initially opposite directions, but that the N one, the north one, then curved over to the quasar in the northwest. It was not until a few years later that I realized that the Narlikar Das model of ejected quasars, which required the increasing mass of the ejected object to slow its initial high velocity, fitted the X-ray observations around the Seyfert galaxies very well. Then the light went on. The North Quasar on its way out had been gravitationally attracted to the companion galaxy northwest of NGC 4319, which had swung it around in the observed direction. But the referee complained because the data tables were not arranged in certain order, and the objects were not discussed in a certain sequence, and it had not been proved that the connections and extensions were not noise. The inevitable ritual was upheld, and the paper was stalled indefinitely. All right, I'm good for now. You guys go.
Yo, thank you,
Anybody read
Stone.
one?
That was wonderful.
Sure thing. My pleasure.
Anyone else want to read? I mean, honestly,
Yeah,
I
I'll
think
go.
that. Oh yeah, you want to
Oh,
jump in
actually,
here,
this
Scott?
might be a good place to. Well, I'll jump in if you want. That sort of seems
Hey,
like a
go
good
for it,
spot
man.
to stop, but yeah, no, I'll read if you want.
Let's see. How long
If you
we've been
like.
going for? We're at an hour 15. How do you feel, Alan?
Yeah, dude. Scott, Scott, take us away for a little bit, brother.
All right, let's go. The IAU Symposium. Fortunately, the International Astronomical Union, IAU, is holding its 3-yearly meeting in Holland in August 1994. By the way, am I okay on sound?
I think
Yeah,
you could be
good.
snugging up to your mic a little bit. Not louder, but
Okay, yeah, I
at
was
the mic.
leaning way back,
Yeah.
so get closer. All right. So a 4-day symposium on examining the Big Bang and diffuse background radiation had been appended. Now my participation was always a matter of doubt, but this time not enough members of the organizing committee spoke out against it to prevent my being invited to give a short paper. By the way, I did just want to pipe up as we're reading through this. I mean, can't help but have a lot of sympathy for this guy, and what he's up against. I mean, regardless.
Yeah, he's a go-getter. I think it's great.
Yeah.
Yeah.
He is the thorn in their side.
Well, he had this one line earlier that I thought about even piping up and suggesting highlighting, that was something about all the ridiculous alternatives that were being offered up, such that like the whole scientific community was wasting their time for several years. Of course, we might argue it was a century's worth or something, but just how I felt like it was illustrative of how just completely lost the orthodox science community can get. I mean, obviously we're all well aware of that, but throwing that in. So I realized I could cram most of the important new observational data on the new cases of X-ray quasars associated with low redshift galaxies into the 5 pages of a camera-ready paper. Even though it would take more than a year to appear in the Little Red proceedings. Yeah, also him publishing in the Armenian things and stuff was kind of funny. It was at least a publication to which interested researchers could be referred to see the vital pictures of the actual X-ray data. Returning early from the peace of the family vacation in the French Alps, I picked up my transparencies and diagrams and headed off to entertain the power elite with deliciously forbidden crackpot ideas. The establishment always confuses data with theories. There were a few other dissidents in attendance to whom it was very important to communicate the new observations. Ayant Narlikar gave a rigorous presentation of how near mass concentrations new matter could be created in the vicinity of old matter. Jeff Burbage gave his usual pungent update of the evidence that some quasars were much closer than their redshift distance. The symposium relentlessly advanced toward one of its high points. The customary authority on extragalactic theory was scheduled to give the inevitable summary of the present state of knowledge. It always pained me that even though everyone knew what was going to be said, it was given the better part of an hour, whereas the new observations, which destroyed the premises and conclusions of the talk, never had enough time to be presented in 15 or 20 minutes, and usually not at all. Clearly, the main purpose of these review of the theory talks was to fix firmly in everyone's mind what the party line was, so that all observations could be interpreted properly. The reviewer of choice was naturally Martin Rees. Now, actually, I know that guy's name. I think he's an Australian. He has popular science books too. The reviewer of choice was naturally Martin Rees, recently having glided effortlessly from Plumian professor to Astronomer Royal of England. After the standard defense of the Big Bang, even though it did not need defending, the only substantive comment from the audience was from the perceptive veteran, Professor Jean-Claude Pecquart, not to be confused with Pecker. He pointed out inconsistencies in the use of galaxy evolution as an adjustable parameter in order to avoid unexpected behavior with redshift in the Big Bang. The final day consisted of a panel of about 9 members picked to represent the range of topics covered during the symposium. Facing the audience on the extreme right was Martin Rees, middle left, Jeffrey Burbidge, and on the extreme left, myself. Rees opened up with a strong attack on the observations I had shown in my short talk a few days previously. When it came my turn to make an opening statement, I showed even more startling observational images that contradicted conventional models. The discussion was then thrown open to the rather large audience, and a Dutch journalist, Govert Schilling, rose to ask Martin Rees a question. The question, roughly paraphrased, was, in view of the evidence Dr. Arpes showed, why have not major facilities been used to further observe these objects? Martin turned toward me and erupted in a vitriolic personal attack. He said I did not understand the evidence from superluminal motions, that I did not believe the age of galaxies, plus a number of other elementary failings. I was rather stunned by the vehemence of this response, and I suppose the audience was also. After a moment or so, I replied that superluminal velocities were not a problem if you put things at their correct distances, and that I, of all persons, should believe the ages of galaxies, because as a graduate student, I had measured the countless stars in globular clusters, which helped establish the only age we have for galaxies. But most important of all, I said, I feel it is the primary responsibility of a scientist to face and resolve discrepant observations.
If only Robot Polisher had been there to clip this up.
Dude,
Yeah.
right?
Yeah.
What an epic response, man. And you know someone's
Yeah.
serious about their game when they were the one that measured the globular cluster. And you're going to come at the globular cluster measurer? Okay, dude.
Yeah, and say he doesn't know what he's talking about or appreciate it. Ridiculous. An amateur observes Mark 205. What apparently set off Rees in response to the journalist's question was that it had been mentioned that an amateur had observed the NGC 4319 Mark 205 connection with the Hubble Space Telescope. Yeah, amateur, automatic disqualification of the data. Since 1971, this had been considered a crucial object in the proof of discordant redshifts of quasars, and in the symposium, I had shown new evidence for the association of further higher redshift quasars with the same system. Because the Space Telescope was reputed to be able to answer all questions, many people had urged us to observe this key object again. Jack Sulentic, a longtime collaborator on this project, and I prepared a complex, time-consuming observing proposal, the kind that automatically sifts out the outsiders. It was not only turned down, but savaged by the allocation committee. So much for that exercise in futility. I was informed later in a letter that it was NASA's policy not to release the names of scientific assessment panels. My first image was of my colleagues in false beards and dark glasses sneaking into the meeting room. Then a less humorous thought occurred to me, that large amounts of public money were being handed out by a secret committee. It was not long before a delightful story started to circulate. The Space Telescope administrators had decided to make 10% of the time available to the community of amateur astronomers. This is actually a well-deserved acknowledgement of an enthusiastic, knowledgeable, and important community. The rumor was that they had asked to observe Mark 205. I did not really believe this until several years later, when the author of the proposal himself walked into my office and put the observations down on my desk. He was a well-informed and able high school teacher who had quite competently confirmed the bridge between the low redshift NGC 4319 and the high redshift Mark 205. I urged him to publish, but to this day I have not seen it in print, and I do not know what difficulties he may have encountered.
I'm shocked.
As a side note, what's that?
I said I'm
Ridiculous.
shocked.
Yeah, it sucks. As a side note, someone observed the galaxy NGC 1073 with the 3 quasars in its arms with the William Herschel telescope in La Palma. I thought I saw some filaments associated with the quasars, but I have seen nothing published yet. Finally, one amateur was assigned time to observe spectroscopically the quasar, which is attached by a luminous filament to a galaxy called 1327-206. But NASA set the Space Telescope on the wrong object. Shortly thereafter, the Space Telescope Science Institute announced it was suspending the amateur program because it was too great a strain on its expert personnel. An even greater embarrassment was, however, that all these objects were drawn from my book, Quasars, Redshifts, and Controversies, the contents of which the NASA allocation committees had been avoiding at all costs. As we will have occasion to mention a number of times during this book, amateurs have a much better grasp of the realities of astronomy because they really look at pictures of galaxies and stars. Professionals start out with a theory and only see those details which can be interpreted in terms of that theory. This is some of the background behind the sensitive point which the journalist raised with Martin Rees in the final discussion panel. The reason the point is so sensitive is that the influential people in the field know what the observations portend, but they are too deeply committed to go back. The result will surely be to inexorably push academic science toward a position akin to that of the medieval church. But if that is the evolutionarily necessary solution, then perhaps we should hasten the process of replacing the present system with a more effective mode of doing science. That seems like a pretty heavy statement. Okay, I got one more, I guess. X-ray observations of galaxy quasar pairs. In addition, I reported for the first time in IAU Symposium 168 the results of pointed Rosat observations on 4 additional galaxy quasar pairs that fell conspicuously close together on the sky. Table 1.2. The probability of these associations being accidental was already very small back in the 1970s, and when the observations revealed X-ray extensions from the galaxies toward the quasars, it not only clinched the physical association of these objects of vastly different redshift, but it also confirmed the ejection origin of the quasar from the galaxy.
Oh, this
Wow.
one is really that's really a work of art, huh?
That's a
Yeah,
pretty
that
high
lower
sperm
left.
count there.
Yeah, these are all very biological looking when they're
They
black
are
and white.
actually. You're right. You're right. They are.
I think that galaxy's pregnant.
It's showing its
Yeah,
globular cluster.
phallic
I
stuff.
still think I've seen him at a urinal somewhere already.
One of these pairs, NGC 4319 Mark 205, has already been discussed here, but the others are mentioned below because of the understanding they add to the nature of the galaxy quasar relation. The 2 most compelling cases are discussed first. NGC 4651, 3EC 275.1. The radio bright quasar 3.
Do you want to keep? Let's see. This is going to be a. Well, it's up to you if you want to read.
Yeah, I
this
can knock it out. I
section
actually just kept going. I didn't even think about it.
Cool. Okay.
I'll just do this one. The radio bright quasar 3C 275.1 is situated only 3.5 arc min from the bright apparent magnitude spiral galaxy NGC 4651. The probability that this would occur by chance is only about 3 in 1,000. But what no one ever calculated was the compound probability that the galaxy it fell so close to would be the one spiral galaxy in the brightest 7,000 that had the most conspicuous jet emerging from it. That reduced the accidental probability to less than 1 in a million. Now Alan Sandage, who had photographed this galaxy in 1956, nervously grasped the implication, but immediately pressed the argument on me that the galaxy jet was not pointing at the quasar, which proved that it had nothing to do with the quasar. Of course, it was only pointing 20 degrees away from the quasar, and subsequent deeper plates revealed that there was material filling in under the jet, down to within a direction only 60 degrees away in position angle from the quasar. See figure 711. But by that time, the configuration had been relegated to the category of disproved associations. Actually, there
already
is
disproved. Well,
yeah. Don't even bother
Debunked.
bringing it up.
debunked. Yeah. Well said.
Never mention it again.
Pre-debunked.
Pre-bunk.
Is that what pre-dunked means? Oh.
It does now. It
Kinda.
can.
Actually, there is an amusing story about the statistical association of the whole group of radio bright 3C quasars with bright apparent magnitude galaxies that G.R. Burbage, E.M. Burbage, P.M. Solomon, and P.A. Strittmacher established. Oh, B squared, S squared. And they found a less than 5 in 1,000 chance of accidental association for the whole sample. When I showed the X-ray extension from the nucleus of NGC 4651 almost to the position of the quasar, Professor J. Trümper, the director of the X-ray section of the Max Planck Institute for Extraterrestrische Physik, I mentioned that this was one of a class of galaxies known statistically to be associated with quasars. He was very skeptical until I remarked that the B squared S squared result had been confirmed by Rudi Kippenhahn, former director of the Max Planck Institute for Astrophysique. After that, he wanted analyses only in the latter form. As I brought more and more results to him, he said, well, I know you can't be right, but I will help you where I can. I had to ruefully admit that that was not completely discouraging. That's how sad it's gotten for him. In fact, it was about as much encouragement as I ever got.
Set that bar really high, buddy.
Yeah, I know you're wrong, but I'll give you a little
Man,
help.
don't you guys feel that times like a million too?
He's like, they were skeptical. I'm like, you guys haven't been skeptical of a single thing in your entire life. Stop lying.
Figure
Crazy.
1.8 shows that X-ray material stretches from the nucleus of the galaxy toward the position of the quasar, where the quasar material extends about to meet it. If the 10.5 kilosec exposure had been just a little bit longer, it might have shown the bridge to be continuous. But does that really matter, considering the low probability of accidental contiguousness? The low probability of such an active jet galaxy being accidentally involved, and the vanishingly small probability that an X-ray jet would accidentally be coming out of the nucleus of the galaxy and pointing directly at the quasar. It would seem to me that a healthy science would eagerly recall all the other cases which pointed to the same conclusion and get on with the job of finding out why.
Did you
Figure
guys catch
1.9.
that exposure? Sorry, just to slow you down for a sec. Did you catch that 10.5 kilosecond exposure? That's where you open up the lens and take in light data for nearly 3 hours just to get the image because of how faint and far away, quote, these things are.
Wow. I had no idea about the unit kilosec. You would think that would, like, so that's 3 hours approximately. You'd think it'd be a small bit of time if it's like a sec. So figure 1.9, figure 1.9 shows another characteristic tendency of these active objects vis-a-vis to exhibit lines of sources emanating from them. Also shown in this picture is the tendency of the lines to be nearly at right angles to each other, something we will see many times. The former is easy to picture in a model where the sources are ejected from active galaxies and quasars. A cause for the latter is difficult to imagine, but when we get a mechanism that gives such ejections, it may be a sign we are approaching understanding. Robert Fosbury, the ESO expert on ciphered galaxies, tells me the optical ejection cones from these active galaxies have deprojected opening angles of about 80 degrees.
All right, so before does anyone else want to read? Scott, you're free to read more if you want to, but you also have put in quite a bit.
You know
Um,
what time it is.
Oh,
Nice.
there
Is it
he
Eli?
is.
Nice. All
Mark
right.
474 and the NGC 5689 group. This is a prototype of the groups which I believe represent the building block units which make up our known universe. Like the groups of galaxies we know the most about, such as our local group and the next nearest large group, the M81 group, the NGC 5689 group, has a spiral galaxy like that of type SB as its dominant galaxy. Actually, NGC 5689 is classified as an SA, but it is the same morphological type of massive rotating galaxy with a large central bulge of old stars, figure 1-10. My attention was first called to it by Edward, whatever that is, an American astronomer friend of B.E.
Kachikyan.
Markarian.
Armenian.
Another Armenian astronomer. What'd you say?
You're
That
good.
first one was Kachikyan and Makarian.
Yeah, I mean, yeah. Another Armenian astronomer had found this very high surface brightness. Ultraviolet rich galaxy, now called Mark 474. Next to it was the lower surface brightness galaxy NGC 5682, which turned out to be a companion to the large NGC 5689, and characteristically had a redshift about 100 kilometers a second greater. Mark 474 had a redshift about 10,000 kilometers a second greater. I felt that the companion should have an associated quasar and looked on the Palomar Schmidt prints for a blue object in the neighborhood. I found it, but it was a little too faint for the poor spectrograph on the 200-inch telescope. I asked Joe Wampler at Lick Observatory to get the spectrum, and it turned out to be a quasar of redshift Z equals 1.94. Mr. Schmitz criticized me for going outside the Hale observatories to get this spectrum on a smaller telescope, but I replied that Joe was the only one who had built a good enough spectrograph, the Wamplertron, to observe the object. Now I had a close triplet of unusual objects which were almost certainly associated, and in spite of their vastly different redshifts. While I was sitting in an MPE working group, my ears perked up when I heard that this Markarian object had been discovered on the survey to be a copious source of X rays. Arguing that such a strong source deserved to be observed in a pointed observation, I was able to obtain a 12,862 sec exposure in the low resolution mode. The initial reduction showed everything I had hoped for. The quasar was well visible in X rays and was connected back to and elongated away from the strong X ray. Seifert?
Seifert.
Seifert. Okay. Actually, it is unusual to see such a faint apparent magnitude high redshift quasar detected in X rays. Figure 1-10 also shows that X ray emitting material is being ejected along the minor axis of the parent galaxy in the system, NGC 5689. The interesting implication here is that even though the presently active galaxies in the group probably evolve rapidly into more quiescent entities, the original galaxy in the group is capable of subsequent ejection episodes. It is also apparent that there are other relatively strong X ray sources aligned in an X pattern across Mark 474. Most of them are identified with blue stellar objects and clearly represent additional quasars associated with this active group. The optimally smooth X ray contours are shown in enlargement in Figure 1-11. Skeptics immediately argue that if one puts two unrelated distributions of photons close to each other, they will meld together to form an apparent connection. Yet, if one thinks about it for a moment, one realizes that they intermingle only in the outer isophotes to form an hourglass like shape. Figure 1-12 here shows an isophotal contouring of two adjacent instrumental point spread functions. It is clear that only the outermost isophotes emerge into an hourglass shape, and all the inner isophotes immediately return to circularity. Real elongated inner isophotes, filamentary connections, and jets look conspicuously different regardless of added noise. You want to show Figure 1-12 now?
Ooh,
Twins.
You
In
guys,
Figure 1-11, one can see that the connection between Mark 474 and the quasar passes close to the companion galaxy NGC 5682, the galaxy which I had originally felt was the origin of the quasar. Now, however, a collaborator in the office next to mine, H.G. Bai, applied a deconvolution program to the data in order to sharpen the resolution.
So you say Quasar? Khazarian? Oh, Quasar. Oh, my bad. Sorry.
I'm not a big fan of like the cuh. Anyways, and discovered a rather strong X ray source buried in the outskirts of the Markarian galaxy. That X ray source was readily identified with a compact but deformed blue object. The decisive aspect then emerged. This new quasar-like object was almost exactly aligned with the known quasar across Mark 474. In view of the close pairings of quasars across Seyfert galaxies which have now emerged, this appears to be just another confirmatory pair across a Seyfert galaxy. The NGC 5689 group is typical also in the pattern of redshifts of the objects in the group. The largest galaxy has the lowest redshift. The smaller companion has a higher percentage of younger stars and a redshift hundreds of kilometers a second higher. There is a very active galaxy with thousands of kilometers a second higher redshift, and finally, very high redshift quasars emerging from the latter. This theme is repeated over and over again. In later chapters, when we consider the redshifts decreasing as the objects age, we will try to suggest some possible reasons for this hierarchical fractal pattern. It would be helpful, however, to know the redshift of the compact blue object, which is on the other side of Mark 474 from the quasar, as shown in Figure 1-13. There is also an intriguing region situated midway between the dominant galaxy and Mark 474. It consists of a string of red galaxies, a string being a non equilibrium configuration which cannot last the age of the galaxies. Containing an X ray BSO. A peculiar dwarf galaxy is less than 1 arc minute away. The picture of this latter group is shown in Figure 1-14 and also in the publication of the proceedings of IAU Symposium 168. How long will it be before some of the numerous large telescopes around the world are used to observe these curious and intrinsically informative objects? So what's he saying here? The blue object and the redshift object, the X-ray, they're shooting at each other, right? That's what he's noticing. Asking a question.
I mean, it's all kind of inconsistent with each other, essentially.
Anyways, okay. NGC 3067 and the quasar 3C232. This galaxy quasar pair has had an absolutely amazing history. Back in 1971, Burbage et al. Derived a probability of accidental association of less than 1 in 3,000. Bokenberg and W.L.W. Sargent found absorption lines of the galaxy in the spectrum of the quasar in 1978 and assumed it was a distant background quasar shining through the galaxy. A chance coincidence. In 1982, Vera Rubin went further and attributed the spectral shift of the galaxy absorption lines to rotation around a massive galaxy taking place at an unusually large distance from its nucleus. Naturally, the latter calculation produced a mass of dark, undetectable matter some 16 times the estimated mass of visible matter.
Oh, they found
Despite
dark
the
matter. Look at that. There it is.
Was it right where they were looking
found
for it
dark
again?
matter.
Oh man.
Despite the enormity of this factor, it was hailed as proof of the existence of enormous amounts of unseen matter in the universe. Despite the enormity of this factor, it was hailed as proof of the existence of enormous amounts of unseen matter in the universe. Okay. But the galaxy was patently not an ordinary galaxy. It was a sharply bounded, very high surface brightness starburst galaxy, a rare and active kind of galaxy, which would make hmm, the accidental association with a quasar hundreds of times less likely. Hmm. Moreover, pictures of the galaxy revealed a shattered explosive morphology with emission line filaments issuing from it. It figures 1-15 and 16. Under no circumstances could it be a normal galaxy in equilibrium rotation, which would be required in order to derive a meaningful mass. The huge derived mass was a complete fiction. Why didn't they look at the galaxy? Actually, I sent pictures, but to no avail. An even more startling development occurred in 1989 when C.L. Carili found a filament of neutral hydrogen leading from the west end of the galaxy directly to and beyond the quasar, figure 1-17. The hydrogen had clearly come from the active galaxy. How else other than being pulled out by the ejection of the quasar? And notice that the quasar falls just at the densest point of the hydrogen distribution with contours of less dense gas trailing back towards the galaxy. This extraordinary result should have cemented the association beyond any doubt, but later it was claimed that the configuration was merely accidental. J. Stock argued that the neutral hydrogen at the redshift of the galaxy absorbed continuum light from the quasar but did not show excited optical emission lines, proving the quasar was quite far in back of the hydrogen filament. Because the other arguments are so overwhelming that we are dealing with another physically associated galaxy and quasar, I reread very carefully the complex calculations they had made. There it was, a short extrapolation. The photons they needed to ionize the hydrogen in the filament and make it fluoresce were at shorter wavelength than those in the spectrum, so they extrapolated to an unobserved portion of the spectrum,
Wow.
which means they just fudged it.
That's that fudge factor. You got it.
That's crazy.
I extrapolated and got half their value. But regardless of how much quasar radiation was extrapolated to be shorter.
Sorry, one second. I'm gonna get this highlight real quick.
Mm-hmm.
Dude, they extrapolated that unabsorbed portion, dog?
Go back up. Hold on. Where was I?
You said, but regardless
Okay.
of
Yeah. But regardless of how much was extrapolated to be shorter than this wavelength, the actual amount would be determined by the amount of hydrogen at redshifts intermediate between the quasar and the hydrogen filament. The degree to which the filament was composed of small, dense clouds and the relative beaming angle between the ultraviolet and radio wavelengths from the quasar. If the conventional paradigm had instead required the quasar and filament to be adjacent, which of these plausible configurations would have been announced as a new discovery? The X-ray fun had only just begun. When the Einstein laboratory satellite went up, it observed the quasar because it was quite a bright object. At a workshop at the European Southern Observatory, I pointed out that there was an X-ray tail coming off the quasar in a direction opposite to the galaxy. Martin Elvis from the Cambridge Center for Astrophysics jumped up and said, "That's noise." I argued that you could see that it was not noise. He said, "I'll look into it and report what I find."
These
He
people
never
love noise,
reported
huh?
back. When I got the relatively short 5600 sec exposure on it with ROSAT, there was the X-ray extension north of the quasar. In fact, there was another cross extension of X-rays, figure 1-18, which quite similar to the configuration around Mark 474. But the most exciting result was that there was a double-sided X-ray jet coming out of the nucleus of the starburst galaxy, NGC 3067, figure 1-19. How many galaxies does one find with such conspicuous bipolar X-ray jets? When I showed this to my MPE colleagues, they became angry at me for saying that I thought the jet was curving slightly around as it extended in northeast, NE, even more toward the quasar, and that a longer exposure might show it leading directly to the quasar. Others said they thought the X-ray extensions from the quasar were just noise. Further X-ray observations on the object were rejected by the allocation committee.
I love how they
Don't
treat them like Rorschach tests.
don't look over here.
Can you see the butterfly? No, man. It looks like a dog's ass to me. I don't know.
Hey, does this look like it refutes your model? No, nope, no, not at all. Looks
Not
like
to
no.
me, nope.
No.
Looks like it proved my model. Looks like it proved it the whole time. Oh, sorry, man.
Sorry, didn't mean to break it up so bad, but I just had to.
Destroyed me. I was like, what am I doing? Where am I?
And they call it science. Oh my god. Anyways, what was the title of this one?
This is Halton ARP. It's called Seeing Red, and it's all about the redshift of the galaxies, essentially.
Oh, no, no, no. I downloaded the PDF. Didn't we hit a new chapter here? I saw
Oh,
bold print.
my bad, my bad, my bad, my bad. NGC 5832 and 3C 309.1.
Okay. The last of the 5 pointed observations that I got with Rosat was a very short exposure of 4,300 sec on one of the Burbage galaxy radio quasar pairs. Only the quasar registered in the galaxy relatively far away at 6.2 arcminute distance did not. The distribution of X-ray sources in the field, however, was very interesting. As Figure 1-20 shows, there is again a strong line of sources running northeast to southwest through the quasar. And the suggestion of a line coming off in almost a perpendicular direction, this configuration was criticized because some of the sources had only 3 to 6 counts. I argued in return that if the background is low enough, just a few counts make for significant sources, as can be well judged visually.
Seek and ye shall find.
Boom. Wow.
Typically,
Well,
right
yeah,
where you look for.
let's wrap it up with that then. That we just knocked out the intro and chapter 1. It seemed like 2 solid chapters pretty much. But yeah, thanks everyone for reading. Scott, Eli, Stone, Alan. That was awesome. Anyone have any thoughts or anything?
Just a lot of parallels with what we're dealing with on a smaller scale.
Yeah, great book. It's like we lived it already.
Yeah, yeah,
Right.
yeah. As we were going through it, my heart was like, very sympathetic to the man.
I feel like I've speed run half of his experiences in the last year, but on a smaller scale.
Yeah.
And all the
Cool.
peer review and all that other stuff we had, are constantly being confronted by. It's just interesting hearing him, call all that out too.
Yeah, and then it's like was pointed out earlier, like, man, you got to give the guy so much credit. He's just like super, just gets up and just like, all right, fine, then I'll go publish it over here instead. Like, you freaking dorks, like these people will publish it, and I'll just keep publishing it and keep publishing it, and you guys will just keep being wrong.
Yeah.
Crazy, man. The guy had a lot of resilience. Well, cool. Thanks everyone for listening in, and again, thanks to everyone that read. That was awesome. It's pretty fun to come together and read like this. Pretty cool thing to do, in my opinion. Everyone, if you want to check us out, oh, go ahead.
I just said agreed.
Yeah, it's cool.
It's also important to give Franco things to do. So when I specifically, ask him to judge how he thinks we're doing and what I think I know and how I enunciate the Greek alphabet specifically, if you could just send me an email with all of your breakdowns, I'd really appreciate it, Franco. Oh, and whoever's Franco's butt buddy is, I don't know his name, but thank you too, bud. Thanks.
It's a Greedo.
Yo, speaking of the Quantum Lads, be sure to tune in tomorrow at 8 p.m. I'll be doing a presentation on quantum mechanics and the mysterious case of who solved it. Because as it turns out, the physical interpretation of all these anti-particles and virtual particle pair collisions and annihilations, etc., all hinges on mathematics that can't be solved by anyone. Oops! So definitely tune in to check that out tomorrow. We'll be going into the history of that.
Number 34. And then on Thursday, we'll do another Twitter X live space. So check us out for that. And yeah, take care, everybody.